Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. I hope you all can hear me.
Good morning, madam.
Okay, morning. All right, okay. I think I'll start now. Okay, I start now. I know people will be joining us later. All right, maybe I think I still have quite a number of people who should be joining us. Okay, afterwards. All right, just to remind you regarding your assignment 3, which is due tomorrow. All right, so again, make sure that everyone submitted or submit their assignment before 5 o'clock tomorrow. Okay, and again, I hope that this time everyone actually follow the instruction. Okay, whereby everybody has to submit to their own group leader or group rep. Okay, so that the group rep can compile and submit the whole thing as one PDF file, and all right, and then upload it into the ULearn. Okay, upload into the ULearn. Okay, so I do not want to receive any double entry this time. Okay, because final exam is just around the corner, so we have to settle all marks, all right, all the coursework mark before the final exam. So I want to mark fast. So that's why I hope that everyone follow the instruction. Okay, follow the guideline. Okay, and again, just to remind everyone, make sure that you also have your attach your cover page. All right, cover page. So the group rep need to also attach the group cover page, and individual has to attach also your individual cover page. Okay, for the assignment, because assignment is actually is an ISO document. Okay, so it will be audited. So that's why you have to that's why we have like a proper like cover page for assignment, etc. Okay, so that when auditor comes, then it's easy for them to actually look at. Okay, so they know that this is assignment what, okay, is from which group, etc. Okay, so if you don't follow that, so then it will be like difficult on us. Okay, so that's why please this time for assignment 3, you really follow the instruction. Okay, all right. Okay, I think we can look at perhaps we can start looking at the question now. We are still in chapter 4. All right, let me just share the content. Anybody got any question to ask before I start? We are still in, I think we haven't finished looking at exercises in sections. Huh? Okay, last week we stopped at this exercise, which is exercise 4.6, okay, on page 159. So perhaps today we can continue looking at exercise 4.7. Okay, so anybody got any question to ask before I start? All right, okay. This section 4.7 basically is about product and quotient of complex number. Okay, and for product and quotient of complex number, this is for a complex number in polar form. So you have a certain formula, all right, certain formula that you can apply. Okay, so if you recall, all right, when you have a complex number in polar form, if you want to multiply, okay, so under the product formula, what you need to do, when you have like two complex number you want to multiply, then the modulus for both you are going to multiply, okay, and whereas the argument for both you are going to add. Okay, so that is for the product formula. Okay, whereas for the quotient, all right, quotient formula, what you need to do in terms of modulus, you divide. Okay, so depending on which one is the first one, which one is the second one. Okay, for example, if you are given two complex numbers z1 and z2, so if question say z1 divide by z2, that means in terms of modulus, okay, r, so then it will be r1 divided by r2. All right, and then argument, it will be theta 1 minus theta 2. But question may ask you like, they give you two complex number, Z1 and Z2. Then they may say Z2 divided by Z1. Okay, so in that case, Z2 is like the first one. Okay, Z2 divided by Z1. So that means in terms of R, it will be R2 divided by R1. And in terms of argument, theta 2 minus theta 1. Okay, so that is your quotient formula of a complex number in polar form. Okay, so then let's look at exercise. Okay, exercise 4.7. All right. Okay, for question 1, okay, you are given Z1 and Z2 are in terms of polar form. So question asks you to find Z1, Z2. All right, this is multiplication. Okay, what's the answer? Anybody? 4.7. What's the answer for this? Okay, but anyway, question is also asking you the final answer. If you look at the question, final answer is in rectangular form. Okay, so can someone give me the answer for Z1, Z2 in rectangular form first? Or what is the modulus and argument for question 1 for the product? What is the modulus for Z1, Z2? And then what is the argument for Z1, Z2? Anyone? This is quite straightforward. What is the R? What is the R? And what is argument for the product? Okay, straight away for the product. Anybody? What is the R? Oh, you locked the mic. Okay. Okay, all right. All right. Can anyone?
R is 2 and 3.
Okay, so that means you multiply. So give me
Yes,
the answer. R
6.
is 6. Okay, what about
6.
argument?
210 cos
Okay.
210 plus
Okay,
sin.
210. Okay,
Uh,
so that means you add. Okay, so once you have your
yes,
R and theta, okay, so the complex number in polar form, in this case for Z1 times Z2 in polar form, you will be writing as 6 cosine 210 plus I sine 210. Okay, but because question asks you to write your final answer in rectangular form, so every time they said rectangular, that means you just need to compute. Okay, just compute this. Okay, all right. So it doesn't matter either you write in terms of decimal or you write in terms of exact value. Okay, all right. So this one basically, if you use exact value, that means I'm looking at 210 as this is actually quadrant 3, right? So 210 is actually, if I'm referring to the reference angle, is 30 degrees. Okay, so it's 30 degrees. So that means cosine 30 degrees and sine 30 degrees. Okay, so if you remember, cosine 30 degrees is 3 over 2. All right, and sine 30 degrees is half. But because this is in third quadrant, okay, so both are negative. So if I'm using exact value, that means, all right, this is 6 times minus 3 over 2, okay, minus 1 over 2 or half I. This is exact value, but you can use decimal, no problem. You can just use calculator, okay. So that means in terms of rectangular form of the answer, it will be, okay, it will be minus 3, 3, okay, minus 3I. So this is answer for question 1. Okay, what about question 2? Okay,
Madam,
yes.
for R, I got 4.
Okay, for R you got 4.
For
How
theta,
much? Okay, oh, you mean for question 2 eh?
uh,
Okay, all right. Okay, for R you got 4. Okay, this is for question 2, and then for argument,
uh, 120.
Okay, 1 to O. All right, okay. So if we look at the complex number itself, all right, in terms of R, it will be 24 divided by 6, right? So that means it's 4, and then 150 minus 30, all right, for the argument, so it's 120. Okay, so once you got that, okay, that means you can write in terms of rectangular form, it will be in the form of 4 and then cosine 120 degrees plus I sine 120 degrees. Again, because question asks us to write our answer in terms of rectangular form, okay? So which means that, again, you can use calculator, all right? Or if I want to use exact value also can, because then 120 degrees, this is in quadrant 2. I am referring to my reference angle, okay, reference angle which is 60 degrees now, okay, it's a 60 degrees. So that means if I want to use exact value, I'm referring to 60 degrees in second quadrant. So cosine 60 degrees is half, okay, and then sine 60 degrees is 3 over 2. And because it's in second quadrant, cosine is negative, sine is positive. So if I'm using exact value, it will be then minus half, okay, and then plus 3 over 2i. Okay, it's like the opposite of the previous question. Okay, because 30 degrees and 60 degrees, if you remember, they are co-function, right? Okay, so then the answer for our quotient, all right, is minus 2 plus 2 sec 3i. Okay, but again, as I said, you can use calculator if you want. Okay, if you don't want to write, or if you don't want to figure out in terms of exact value, you can just straight away use calculator, no problem. Okay, all right. Question 3 then. Any questions so far? Okay. Okay, this time, question 3. Okay, Z1 is 2 plus 5i over 1 minus I, and Z2 is 4 minus I over 3 plus 8i. So find the modulus and the argument of Z1, Z2. Okay, so basically what you need to do, all right, because your Z1 is given in terms of that particular expression, okay, in terms of quotient. Okay, so you actually have the option for this question, this type of question, you have the option. Either you want to straight away change everything in terms of polar at the very beginning. That means 2 plus 5i, you change to polar. 1 minus I, you change to polar. And then when it comes to division, you use the formula earlier where you divide two complex number in polar form. That is one option. Or another option, you straight away carry out the operation of division using the rectangular form itself. Okay, 2 plus 5i divided by 1 minus I. So when you divide complex number in complex number in rectangular form, you straight away multiply by conjugate of the denominator. Also can. All right. So then final answer for Z1, definitely you will get rectangular form. Okay. And then Z2 also similar. But after that only you find modulus and argument for Z1, Z2. So you have the option. It's up to you. Okay. But anyway, if anybody got the answer already, what's the answer for modulus for Z1, Z2? Anybody has done this? What is the modulus of this Z1, Z2 straight away? And then argument also, if anybody has actually compute this. Okay, anybody has done this? Okay, it's just that this question is a bit lengthy in terms of solution, because you have to figure out first. You have to divide first for Z1. Okay, you have to find the quotient first for Z2 separately. Okay, then only you have your polar form for both. Okay, then only finally you can find the Z1, Z2. Okay. Okay, anybody has done this? Would anybody would like to share the answer? Okay.
1
Yep.
point 1.6.
Okay, for modulus, is it? Okay,
Modulus
1.6
plus
argument.
0.
Sorry, second, Shami.
For modulus,
Okay, for modulus 1.6.
Plus 0.90.
Now you straight away give me the answer for modulus. You already
Oh,
means
1.6 plus 0.90.
for modulus
Yes,
1.6 plus
0.9.
0.9. That means 2.5. Is that your modulus?
For Z1?
Huh?
For Z1 kan itu?
Modulus. Is this your modulus for Z1, Z2?
No, my final answer for argument.
Oh, for the argument you mean?
Yes,
What is your argument?
1.6 plus 0.9.
Argument is in terms of degree. It's an angle. Are you saying 1.6 degree?
Oh, no. Set 29/2 for argument. Set 29/2 and set 17/73.
Shami, argument is angle, right?
Yes, for
Okay.
modulus, I got set 29/2.
Set 29/2. This is your modulus.
Uh,
And your argument?
set 17/73.
Set 7.
Argument I got 389.7.
Okay, 389.7 degrees, right?
Yes.
Okay. So modulus, you got set 29.
Madam, modulus I got 1.83. Sorry.
Okay. All right. 1.83.
Yes. I confused.
Okay.
Sorry.
Okay. All right. Okay. 1.83. Okay. This is final answer. Okay. All right. Okay. So modulus is that. So that means you're based on this, which means that what you have found for your Z1, Z2 is 1.83 cosine 389.7 degrees plus I sine 389 degrees. Okay. This is the polar form lah. Okay. For Z1, Z2. All right. Okay. Anybody got any different answer?
Madam,
Yes.
my angle I got 29.72 degrees.
Okay. 29.7. Okay.
2. Yeah.
Sorry. 29.7. Right? 7.2 or
Yes,
7,
madam.
Okay. All right. Okay. Thank you. Okay. So if you look at in terms of the argument, okay, because we said that argument has to be between 0 and 2 pi. Okay. So which means that, okay, if it is 389.7, all right, you can subtract 360. Okay. So what we get is 29.7. All right. Okay. So, okay, for this particular question, okay, if let's say people write 389.7, okay, just to answer, for example, the question say find modulus and argument. Okay, so then people give us in terms of 389.7 like this. Okay, during exam normally we will also accept, but again, if people give us 29.7 also we will accept. If they just mention like this, okay, state only argument is this, modulus is that. Okay, however, if let's say question say, okay, you find Z1, Z2, okay, Z1 times Z2 in polar form, for example, in polar form. Okay, so that means until this stage, you cannot leave your answer. You still have actually one last answer, all right, that you have to write in terms of data between 0 to 2 pi, which means final answer has to be written as like this. Cosine 29.7 plus I sine 389.7. Why? Because during final exam, there will be one last mark, which is for this one. There will be mark for this one as the final answer. So which means if people don't state this, people don't get that one mark for the last answer. Okay, all right, because this will be our final correct answer, which our argument has to be between 0 to 2 pi. Okay, 0 and 2 pi. Okay, but if let's say question just say find modulus and argument, then they full stop. Okay, so you state like this, okay, and then you state like this. Okay, both actually we will accept. Okay, both we will accept. Okay. All right. Okay. Thank you. Okay. The rest of you, do you understand how your friend got this answer? Okay. This is actually is a correct answer for both modulus and argument. Okay. For this question. All right. Okay. And then we come to the last exercise, which is 4.8. And then after that, we can look at our chapter exercise. Okay. For exercise 4.8, this is now De Moivre's theorem. Okay. So De Moivre's theorem, again, this is a theorem whereby you want to take care of any powers of complex number. Okay, and for this theorem, you need to, in order for you to apply this theorem, all right, your complex number has to be in polar form. Okay, it has to be in polar form. So if it is not in polar form, it will be difficult for you to actually find complex number with power. Okay, so it has to be in polar form, then only you can use De Moivre's theorem. But if question mention use De Moivre's theorem, okay, even though it's only, like for example, question give you one complex number, let's say just a simple 2 plus 3i power 2, and then but question mention use De Moivre's theorem, even though it's a simple power like this, if this is mentioned, you must use. Okay, so you must use, even though this one is simple, that means you can actually expand this twice. All right, that will be actually a bit faster, but because this word is mentioned, so you must apply this. Okay, because during exam, if this is mentioned, that means we want to test you on using the theorem, so you must use theorem. So if you expand without theorem, that means you don't get marks for that. Okay, for the method. Okay, so again, using this De Moivre's theorem require you to change to polar, because then only with power, according to this theorem, what you need to do then, the modulus, all right, you also raise to that power, all right, and then whereas argument, you multiply the argument with that power. Okay, so that is De Moivre's theorem. Okay, so let's look at exercise 4.8, question 1, question 1a, perhaps. Anyone? Any answer? Anybody would like
The
to?
answer is negative 12.256.
Okay, what is, okay, question asks you to find
Oh,
z power 4.
okay.
Okay, straight away you
The
give me the answer in terms of course this is polar. So
for the modulus is 16, argument is 140.
okay, so 16 cosine. What did you say just now? What's the argument?
140.
140. Okay, so that means,
yeah.
okay, so that means this is the answer. Okay. Okay, now solve using De Moivre's theorem, but final answer is in the form of a plus bi. Okay, so answer must be in the form of a plus bi. Okay, so which means you still need to, okay, is this your answer for z power 4 just now? For cosine 140?
Not yet, madam. Need to finish it.
Because this is power 4, isn't it? Okay, all right. So what you need to do, you just need to compute cosine 140, all right, and then sine 140. Can you give me the final answer?
The final answer is negative 12.256.
Negative, sorry, say again. Negative
Negative
12
256
256.
point
Okay,
plus 10.288 I.
10.288I, Okay. Anybody got differently? Okay, this one. All right. Okay. Then let's move on to B. Okay, I suppose this is the right answer. So, okay, let's look at B. Okay, what about B? What's the answer for B? For set 3 plus I power 11. Anybody? Set 3 plus I power 11.
Seven one.
Madam,
Okay,
uh,
all right.
1024,
1024,
set 3
set 3
minus
minus,
1024I.
okay, 1024I. Okay,
Yeah.
all right. Okay, thank you. Anybody got any different answer? Okay, all right. Okay, so this is the answer for B. All right. What about question 2? Okay, question 2. Set 3 plus I power 4 times 2 plus 2I power 6. This is actually like similar to your assignment, isn't it? But I think assignment also got division as well. Okay. Okay. Any answer? Anyone? Anybody?
Seven one to 7.4.
7. Okay, this is the final answer, eh? Okay, the final
Yes.
answer for uh hold on. Hold on. This is the final answer for um set 3 plus I power 4 times 2 plus 2I power 6. Okay, what's the answer? Say again.
7.1 to
7.1 to 7.4
7.4 plus 4096I.
Okay, 4096I. All right. Okay, anybody got any different answer? Okay. All right.
Madam, I got different.
Okay. Which one?
The front one. I got
Okay, what did you get?
7096.3.
0.3. But 4096 same.
Yeah.
4096I. Okay, same. Okay, so this one, this part, whether this is okay. Anybody else got any different? Okay, I think previously we have done this question. I think the answer for this one actually previously was this answer. They give in terms of exact value 4096 set 3. Maybe we can compute this 4096I. Okay, so for this is actually 4096. So it will be 7095. So something like this one. This one is actually the closer one. Okay. All right. So I think just make sure that people calculate correctly. Yeah. I think because the answer previously was 4096 at 3. This is exact value. But of course, if there's a discrepancy in terms of decimal, okay, because people, if we bring decimal along the way, of course there will be like some approximation error. So but the closer one for if we compute 4096 times 3 is actually 7094.5. So 7096, I think that one is closer. Okay, so 7127 is a bit far. Okay, is farther. So just double check again, calculation. All right. Okay, so that is question 2. All right. Any questions so far? So basically, these are all our exercises in each section. Okay, so then let's look at exercise chapter 4. Okay, now for exercise chapter 4 on page 168, okay, we are not going to look at everything because basically questions are a lot. So I'm going to just perhaps look at certain selected question, but we can actually go through, first of all, we go through all, okay? And if there's any question, okay, people can just ask, Okay, but if you look at exercise chapter 4 on page 168, I think for question 1, okay, question 1, this is just straightforward addition and subtraction of two complex number. Okay, so I think for question 1, all right, I hope I am right that I think this all 3 question you can actually do this, okay, without any problem. And in terms of calculation also, I think you can actually calculate this correctly. Okay, because this is just quite straightforward. So when it comes to addition and subtraction of two complex number, these are given in terms of rectangular form. So we have understood that when it comes to addition, subtraction, we add and subtract real part with real part, imaginary part with imaginary part. So we don't mix up. Okay, so I think that one should be okay. Okay, if you think it's not okay, you let us know. Okay, so then we can take a look. Okay, I think question 2 also. Okay, question 2 also. A, B, C, D. I think also this one should be okay. Also, because again, you are given two complex number in rectangular form of complex number. Okay, and then again, like part A, you just add. Of course, you have a scalar multiplication there. 2 times Z1. That is just a scalar number. So you can just multiply that scalar to your A and B, okay, because you have in the form of A plus BI, okay, and then you add, okay, I think B also should be okay, all right, even though you have like I times Z1, just multiply that I, okay, so Z1 times Z2 also, I think you can expand, okay, the multiplication, okay, Z2 divided by Z1 for D, okay, you have done this, I think, many times also. Okay, so you divide two complex number in rectangular form. You just make sure you multiply by conjugate of the denominator. Okay, so I think you can do this. Okay, now complex number is not difficult, but it is actually it's a bit tedious. To some of questions, it will be a bit tedious and it requires lengthy of solution. So that means you need to have a patience and passion to actually solve this. But it is not difficult. Okay, it is not difficult. Okay, but you have to compute correctly. Try not to make any careless mistake in calculation. Okay, question 3 also. I think you can also do this. Okay, because this is just again it's a division like part A. All right, part A is division. You have done. If you have done like previously, question 2 just now, okay, for D is similar, okay, and then question B also, okay, you just need to expand first your numerator, 2 minus I times 4 plus I, you expand first, and then you have in the form of A plus BI, then you divide by 4 minus I, then it goes back to like part A, so it's similar, just multiply by conjugate, okay, all right, C, okay, C also, I think it should be okay. Okay, but you have to expand first your 4 plus I at the denominator expression. Okay, but make sure that you use the binomial expansion correctly. Okay, so just to remind everyone, okay, that 4 plus I again, if you have in the form of something like this, okay, this type of expression, it is actually is not like this. Okay, sometimes I have to highlight this because sometimes we will have this sort of mistake during final exam. Okay, so you have your binomial expansion. Okay, so this is in the form of a plus b power 2. So you remember you have a squared plus 2ab plus b squared. This is what we call binomial expansion. Okay, all right, so make sure you do this correctly, or you can also, like, this is the same as you expand also twice, so you can do this. All right, so either one. Okay, so just make sure that you do that correctly. Okay, so for C also, I think it should not be a problem if you understand how to do this. You settle your denominator first, then you will get in the form of also a plus bi. All right, then only it comes back to your previous a and b where you need to divide. Okay, you divide a complex number in rectangular form. Okay, and just mind you that for every time there's a I squared, don't forget to change. Okay, so to -1. Okay, every time you have a complex number, you are bound to come across like I squared, especially when it comes to multiplication. So every time there's a I squared, change to -1. So make sure it's correct, plus minus. Okay, so D also, I think it should be okay because it's all like similar. Okay, basically question 3. Okay, it's all like require you to multiply by conjugate of the denominator. So this is actually is an exercise for you to divide two complex number in rectangular form. Okay, so that is question 3. Okay, so far okay, I think you can do it. All right, you just need to trust your answer, but if you want to check, as I mentioned, always you compare with your friends. Okay, ask your friends. Okay, so ask your friends to do the same question, then just compare the answer. Okay, question 4. All right, find question 4 is find z bar in the form of x plus yi or iy. This is just to find in terms of conjugate. Okay, what does it mean? It means that you are given, for example, like question A, you are given z equals 1 plus I, divide by 2 minus I. You need to divide first. Again, this is back to the quotient again of rectangular form. So divide this complex number first. Once you got your answer, all right, let's say you got your answer in the form of something like, for example, you got like this, your final answer. Okay, then only your final last answer you must state, because question wants in terms of z bar. Then only last answer, don't forget to state the conjugate of that complex number. Okay, so this part is only the last stage. All right, you can settle this one first. You divide, okay, again, two complex number in rectangular form, multiply by conjugate, all right, of 2 plus I, 2 plus I. Okay, all right, so you settle that one. You multiply first, like, okay. So final answer, you got like this. Okay, after you have divide, you got something like this. For example, x plus yi. Then only this is actually the last answer that you have to state. Okay, so with the bar, so don't forget to change, okay, the sign of the imaginary part. Okay, so again, I think you can do this. Okay, because you have done like the earlier question, like question 1 to 3 is question 2 and 3 all required quotient division. So this one also same, division also. So this is like you have been doing the same thing all over again. Okay, so I hope by now you already master. All right, this one you have mastered all this. Okay, it's just at the final answer, don't forget to state this. Okay, all right, and B also similar. So I think this one should be okay for question 4. All right. Okay, now perhaps question 5, we can look at question 5 maybe. If anybody have the answer, maybe. For question 5, you are given z equals 1 minus 2i. Okay, find the values of x and y if z plus 1 over z equals x plus iy or yi. Okay, so for this question 5, how to do question 5? Basically, you just need to carry out the operation like the left hand side of the equation there. Okay, you are given this, all right? Okay, and you want to find x and y such a way that you are given this equation z plus 1 over z bar, there's a bar there, equals to x plus yi or iy. Okay, so what you need to do is you need to do this. All right, you want to add this first, settle this part, or carry out the operation on this left hand side, and then your answer you write in the form of your a plus bi or x plus yi. Then you compare what is the real part, what is the imaginary part. So that's when you get your x and y. Okay, I hope you understand this. Perhaps those who have done this, can you share me the answer? What is your x and y? What did you get? Anyone?
6 over 5.
Okay, x equal
6 over 5.
Okay, what about y?
Negative 8 over 5.
Negative 8 over
5.
5. Okay, anybody else got any different answer for those who have done? Anyone? Okay. Okay, anybody got any question for this question, or anyone don't understand how to do this? Okay, you just need to make. Okay, yes.
Show the calculation.
Say again.
Can you show the calculation?
Oh, okay. All right. Okay, let's look at this. Okay, so as I said, you just need to do this one. Okay. So you need to compute z plus 1 over z bar. So which means z is 1 minus 2i, that is z, plus 1 over z bar. Okay, z bar, it will be 1 plus 2i. So this is the operation that you want to do. Okay, all right, so perhaps what you need to do, okay, you settle this part first. 1 plus 2i, you multiply by 1 minus 2i, 1 minus 2i. Okay, so this one stays first, but you settle this part first, the quotient. Okay, up here it will be 1 minus 2i. Denominator, you can use the concept, all right, remember, a squared plus b squared. Or if you have forgotten, all right, if you overlook that these are conjugate, okay, these are conjugate, that you can use a squared plus b squared. If you have overlooked that, you can just expand. Okay, you expand terms. Okay, so if you know that these are conjugate pairs, you can straight away use the a squared plus b squared. All right, so which means this is 1 minus 2i plus, okay, you have your 1 minus 2i over 5. So which means this is the one where you have your 1 minus 2i plus your 1, okay, 1 over 5. Okay, this is actually, it's like the whole thing like this, eh? So if you don't forget, make sure correct, plus minus is correct. So it's plus 1 over 5 and then minus 2 over 5 I. Okay, so then this is the one where you just need to add, subtract real part with real part. Okay, so real part with real part. So that means, okay, 1 plus 1 over 5. So that will be 6 over 5. Okay, so minus 2. Okay, minus 2i, minus 2 over 5i. Okay, minus 2, minus 2 over 5. What is that? Minus 12 over 5, isn't it? Is that right? Isn't it? Okay, what did your friend got just now? Okay, minus 8 over 5. So this is actually is minus 12 over 5. Charis? All right. Charis, are you there?
Yes, madam.
Okay, so minus 12 over 5, isn't it?
I don't know. Because the first step I did was I multiply the, how to say, I take away the fraction first, then only I do conjugate.
Oh, okay. All right. Okay. So you have to conjugate first this one because it's a 1 over
If
z.
if I
Wow.
make the fraction as I make the denominator the same first time,
This one.
that means the 1 minus 2i, I make the denominator to 1 plus 2i.
Oh, so that means you don't do like this. You don't do like this.
Wait, madam. But, madam wrote the question wrongly.
Oh, okay. All right. Okay. So okay. All right.
As
So
1,
just make sure.
1 over 1 minus 2i.
Oh, 1 over 1 minus 2i. Okay. All right. So it should be 1 over 1 plus 2i. Then you conjugate this one, eh? So based on this, so that means the answer is actually, so then once you get this, okay, so that means you just need to compare. Just now is 6 over 5 or 12 over 5i. So you compare with just now x plus yi. So then only you compare x and y. So the answer will be x is 6 over 5. X is for the real part. Y is for the imaginary part. All right, which is then minus 12 over 5. Okay, so that is the answer. Okay, Bashira?
Okay,
Okay,
madam.
so all right. Okay, so that is question 5. All right. Okay, question 6. Okay, question 6 now. Question 6 now is about a polar form. Okay, you have done this. So basically, you are given a rectangular form, all right, in the form of x plus yi or a plus bi. Then you just need to find r and theta. Okay, so the thing that you need to be very careful is the argument. Okay, because argument make sure it is in the right quadrant. Okay, angle in the right quadrant. So that means you need to identify firstly that your complex number lies where, lies in which quadrant. You can plot, or if you can determine straight away from the equation, from the expression given, you determine, because plotting basically is optional. Okay, plotting is optional. But if question say plot and etc., then if the question mention the word plot, you have to plot your complex number. But if they don't mention the plot, like this one, just express each complex number in polar form. But if you do not know how to identify, all right, where your complex number lies, so that means you need to try to plot. Okay. But if you understood, if you have understood this, you can just you can tell. Okay, like for example, like a 13 plus 3i. So it's understood this is positive positive. So that means this complex number is in quadrant 1. So angle must be in quadrant 1. B also minus 19 plus 9. So minus positive. So that is actually is in quadrant 2. Okay. C minus minus. So you know minus minus is, it means quadrant 3. Because you need to identify the quadrant, because you must make sure that you get the right theta. Because when you compute for your argument, tangent inverse will always gives us in terms of angle in quadrant 1 or quadrant 4. Calculator will give us that, because remember I always tell you that calculator follow the restricted domain for tangent inverse. Okay, because by definition tangent inverse last time when we did inverse trigo, tangent inverse, the restricted domain is from minus pi over 2 to pi over 2. That means in terms of quadrant, it's in quadrant 1 and quadrant 4. So calculator will follow that. If your y over x is positive, calculator gives you angle in quadrant 1, acute angle. If your y over x is negative, calculator will give you quadrant 4 angle. They give you negative something degrees. Okay, but if complex number lies in quadrant 3, you make sure you get the right angle. Okay, so that's why you got to determine, okay, complex number lies in which quadrant. Okay, perhaps maybe for question 6, okay, maybe we can just take a look at maybe we look at perhaps one question maybe. Okay, because I think that you can do this. Maybe we can take a look at perhaps C maybe. Anyone? Okay, where you have your minus 2 set 3 minus set 5i. Okay, those who have done this, or you haven't done, can maybe I give you like 1 minute. You can do this. Compute your R and theta quickly. Maybe 1 minute. 1 minute also too long, isn't it? 30 seconds. I think you can do this because you have a formula. R equals to square root of x squared plus y squared. Theta is tangent inverse. Just use calculator. Okay, maybe somebody can give me the answer for R and theta. For question 6C.
Madam,
Okay, what's the R?
square root 17.
Okay, what about argument?
83.
Second?
83. 83.
Hey, come on. Okay, this is quadrant what just now I mentioned.
Okay.
Give me the right. Give me the right angle. Give me the right argument. Complex number lies in which quadrant? I mentioned just now. See?
147.
Not quite. Because this is quadrant what? Minus 2 set 3 minus set 5i is in which quadrant? Quadrant 1, 2, 3, 4. Which quadrant?
3.
Quadrant 3. So quadrant 3, you must give me argument in quadrant 3.
2,
So
3,
the
7.
2, you got
2,
2,
3,
3,
7.
2,
7.
3, 7 degrees. Okay, let me just check. Let me compute also. Straight away, just compute tangent inverse. Okay, make sure. Okay, sorry. Okay, I changed my mode first. My mode is in radian. Okay, I want to use degree. Okay, make sure we are in the correct mode, or make sure you know what mode you are in for your calculator. So tangent inverse. Okay, so then it is minus set 5 over 2 set 3. Okay, bracket set 5. And then divide by 2 set 3. Okay, so calculator will give me 32.842 something. This is acute, but I want it in the third quadrant. So I just add 180 degrees. Okay, I just add 180 degrees, whatever I got just now, 32 point something. I just add 180 because I want it to be in the third quadrant. Okay, so then I should get 212.8. Okay, double check your angle, this one. Check again with your calculator. So it should be 212.8. Or if you want to use it in terms of nearest degree, 213. Okay, so it doesn't matter 1 or 2 decimal or nearest degree. Okay, as long as it doesn't mention anything in the question, you can just give us either nearest degree or 1 decimal or 2 decimal. It doesn't matter. But make sure you compute correctly using your calculator. Okay, just now, Nazira, is it Nazira? Nazira?
Okay, madam.
Okay, can you check again using your calculator? Try compute again. Make sure you compute correctly. Use again calculator and then try press again tangent inverse, and then okay, I do not know how your calculator works, but like mine is I have to like put a bracket, tangent inverse bracket, and then set 5. Okay, I don't need to put minus because I know that it will be like minus divided by minus here. So straight away set 5 divide by 2 set 3, close bracket, and then press the answer. Okay, so make sure you compute correctly. Okay. So if you want to get full marks in the question for question, so make sure you compute correctly. I know that people can understand how the process works, how is the solution, okay, how to do this, how to solve. But sometimes because of a mistake, all right, in calculating, perhaps using calculator, that's when you got a wrong answer at the end. So then it actually you lose mark, okay, you lose mark. So it's a bit it's a bit sad actually. All right. So try not to make any careless mistake in calculation. Okay, I suppose the rest of the question for question 6 also similar. So when you got your R and theta, question asks you for complex number in polar form. So that means for this question then, polar form is in this form, 17 and then cosine 212.8 plus I sine 212.8 degrees. So this is polar form, all right, for question C, okay, question 6C. All right, okay, it's already 9 o'clock. We can take a break for 5 minutes, okay, and after that we will continue looking at question 7 and the rest. I think I'm going to I plan to actually finish off discussing until question 14 today, so that next week we can look at vectors straight away, okay, because next week is our final week and our last week of instruction, okay. So next week we have to like marathon for all question for chapter 5. So today I plan to finish off until all question by question 14 until question 14. Okay, so we take a break for 5 minutes and then we'll continue. All right. Okay, everyone. Okay, 5 minutes break. All right. Okay, is everybody there?
Yes, madam.
All right. Okay, can we continue? All right, let's continue this. All right. Let's look at question 7 now. Okay, question 7. Find polar form for Z1, Z2. Okay, it's a product. Okay, Z1 times Z2. And then Z1 divided by Z2. And 1 over Z2 is 1 over Z1 by first putting Z1 and Z2 into polar form. Okay, so you are given A and B, all right, and then all complex number are given in rectangular form. So you have to find a product, a quotient, as well as a reciprocal expression. Reciprocal is 1 over, okay, 1 over Z1. Reciprocal expression, okay, in polar form. Okay, but question mentioned by first putting Z1 and Z2 into polar form. Okay, all right, okay. Except for, I think, the reciprocal, I'm looking at the question. Okay, for Z1, Z2, for product as well as for quotient, it's fine. That means for this question, you can first putting your Z1 and Z2 into polar form, and then you can multiply as well as divide using your product and quotient. However, when it comes to 1 over Z1 like this, okay, if you have a reciprocal expression, I don't think that you can find reciprocal in terms of polar. That means you cannot like 1 over r cosine theta I sine theta. Okay, you cannot find this. Okay, because you don't actually learn about there's another theorem. Okay, remember De Moivre's theorem. De Moivre's theorem is where you have z power n. If it's a De Moivre's theorem, okay, De Moivre's theorem, z power n is where n is positive integer. Okay, it's positive integer. That means n is greater than 1, etc. Of course, De Morgan's theorem, your z has to be in polar form. Okay, so which means that if you want to find something like this, a reciprocal expression in terms of polar, this is actually require you to actually use something like r cosine theta plus I sine theta, the whole thing power like -1. And power minus one is not positive integer. Okay, that is a negative integer. Okay, there is actually theorem for that, but it's not De Morgan's theorem. So and we don't cover that in our syllabus. Okay, so for this particular question, for 7, for this reciprocal expression, you cannot use this z1 here in terms of polar. You have to use in terms of rectangular form first. Okay, that means for 1 over z1, you have to make sure that you settle the reciprocal in terms of rectangular form first. Means 1 over z3 plus I. Okay, then only, right, you find your reciprocal, you multiply by conjugate, then final answer, then only you change to polar. Okay, so that means that question where I said that putting z1 and z2 first in terms of polar, that is only to answer for product and quotient. But reciprocal, it has to be in terms of rectangular. Okay, never mind. Let's look at, maybe we look at the first one. 7a. 7a. Let's look at 7a, where you are given z1 equals z3 plus I, and then z2 you are given 1 plus z3. Okay, anybody has done this? Can someone tells me in terms of a polar form of complex number for both z1 and z2? What's the answer? What's the polar form of complex number for z1 and z2? Anyone? You give me first your polar form. Those who have computed this. What is z1 equal?
Beda.
Okay. All right. Okay. Nabila.
2
Z1. 2.
cos 30
All right. 30 degrees plus I sine 30. Okay. What about Z2? Have you computed?
2
Okay.
cos 60.
All right. Okay. Thank you. Or you have also found your product and quotient. Nabila.
4
Okay.
cos 90.
Okay. And then for quotient.
Cos
Okay. R is 1, isn't it?
yes.
Okay. What about an argument?
Negative 30.
Okay. But after that, what you need to do?
Tukar.
Okay, you write in terms of positive angle, right? Using the coterminal, coterminal concept, coterminal angle. So that means it will be 330. Okay, because minus 30 is going this way. That is minus 30 degrees. So you give us the coterminal angle this way, which is a positive angle. So that is 330. Okay, all right. So that is our. Okay, I suppose everyone else also got the same thing for this. Okay, any question first for product and quotient? Okay, so this is what I said just now. Okay, so Z1 and Z2, you can straight away find in terms of polar. Okay, in terms of polar form. So then when it comes to a product as well as quotient, it will be very straightforward. Okay, applying that formula. So if these two are the correct polar form, then product you just multiply, okay, the modulus, argument we add. And then here when it comes to division, okay, so we divide our modulus. 2 divided by 2 is 1. And then in terms of argument, because it is 30 minus 60, so we, sorry, yeah, 30 minus 60, so then we got minus 30, okay? But then again, as I said, minus 30 is negative direct, this is a negative angle or clockwise direction. So what you want is the anti-clockwise or counterclockwise direction that will give you your positive angle, because then argument is between 0 and 360 degrees, okay? It's only using positive angle, okay? But then the next question is asking you for 1 over Z1. So this is the one I mentioned, okay? So if you want to find, for example, 1 over Z1 is, in terms of polar, is 2 cosine 30. 2 cosine 30 plus I sine 30. Okay, this one actually, because up here is 1, so down here is a polar. So you don't have actually some sort of like a formula, okay, when it comes to a reciprocal of complex number in polar. Okay, reciprocal means 1 over. Okay, so in this case, because another way of doing is actually is using like this. Okay, you have like power, the whole thing is actually reciprocal means is power minus 1. Okay, but because our De Morgan's theorem is actually our De Morgan's theorem is only for n is positive, okay, or positive integer. Okay, so in this case we cannot actually use our De Morgan's theorem. Okay, now, but in a way, technically it's like, how do I say? It's actually can. Okay, it can be done, but technically it can be done if you want to follow. But actually, it is actually some sort like, remember last time I mentioned, sometimes wrong method can give us correct answer. Also possible, Also possible. Okay, wrong method can give us correct answer, because if I say wrong method means that if we want to use De Morgan's theorem, De Morgan's theorem said that if this is our n, remember this is our n, our power, okay, this is power. So then what we need to do, okay, r we raise to that power, okay, we raise to that power, and then in terms of argument, okay, in terms of argument we multiply, okay, we multiply. So that means you can actually do like 2 power minus 1 like that, okay, and then you got like minus 30. All right, something like that. But actually, perhaps the modulus maybe is, you can see it's actually is correct, but not the argument. Argument is actually is wrong. Okay, because in the first place, this is actually negative number. De Morgan's theorem, power has to be positive integer. So that means by right we cannot use De Morgan's theorem for this. So that's why when it comes to a reciprocal 1 over, it is not for polar form. Okay, it is not about polar form. So what you need to do when it comes to this particular question, for this question, it has to be in rectangular form first. So that means you have to, okay, for 1 over Z1, you have to use your Z1 in terms of rectangular. So rectangular for Z1 is actually is Z3 plus I. So you have to find using this method first, reciprocal of a rectangular form, not in polar form. Okay, so that's when we said that, okay, if we have a 1 over, it's the same like our any other quotient of a rectangular form of a complex number, you are to multiply by the conjugate expression. Okay, so conjugate expression. Okay, so simplify. Okay, numerator is just 3 minus I. Okay, denominator, you can just use your a squared plus b squared. All right, so then you will get your 3 plus 1, all right, which is then 4. So that means your a plus bi is in the form of 3 over 4, okay, and then minus 1 over 4i. So this is your reciprocal form, 3 over 4 minus 1 over 4i. Okay, then only you change to polar. Okay, then only, all right, this whole thing, which is your 1 over Z1, you change to your polar form. Okay, but first of all, okay, cert 3 over 4 minus 1 over 4i lies in which quadrant? It's in quadrant 2, isn't it? Okay, because then you must make sure later on our argument must be in the correct quadrant. Okay, so that is in quadrant 2. So we make sure that later on our angle must be is a right angle in quadrant 2. Okay, so that's when after that you straight away find what is your r and theta. Okay, so you just find your r and theta. Okay, so then you have your this is your 3 over 16 plus 1 over 16. So that means it's 4 over 16, 1 over 4, square root of 1 over 4. That means it's 1 over, square root of 1 over 4 over 16. So 1 over 4. So that means it's 1 over 2. So that is r. And then theta, tangent inverse, okay, minus 1 over 4 over 3 over 4. So that means we can just cancel our 4. So that means you are computing for tangent inverse using your calculator. Minus 1 over 3. Okay, 1 over minus 1 over 3. This is a common angle. We always use this previously. Okay. Tangent inverse. Let me just compute this. Tangent inverse. You can also compute with me. Tangent inverse of minus 1 over 3. Okay. Calculator will give you minus 30 degrees. Okay. Because remember, negative. Okay. Negative. So tangent inverse negative. Calculator gives you quadrant 4. Alright, but we said just now, our complex number is in quadrant 2. So we use a reference angle 30 degrees in quadrant 2. So which means in quadrant 2, our angle will be 150 degrees. Okay, for quadrant 2 angle. Okay, use the concept of your reference angle. So this is minus 30. So that means you have this is 30 degrees. So what you want is this angle here.
Madam,
Yes?
isn't it supposed to be in quadrant 4?
Oh, okay. Sorry. Yes, correct. Positive, negative, isn't it? Okay.
Yeah.
Correct, Cherise. Correct. You are right. Okay. Sorry for the mistake. Okay. So that means this is correct. All right. It's just that you just need to use 330. Okay. Sorry. You are right. Okay. All right. Okay. Thank you. Okay. So then this is right angle. You just make sure you write in terms of a positive. All right. Positive angle 330. Okay. So then only your complex number here, which is your 1 over z1. Okay, 1 over z1, which is in the form of, okay, set 3 just now, set 3 over 4 minus 1 over 4i, set 3 over 4 minus 1 over 4i, which is then you get your r cosine, and then 330, okay, plus I sine 330. Okay, what I would like to just show you something. Okay, this is the answer. Oh, sorry. I just want to show you something. Sine 330 degrees. Okay. Okay, what I would like to show you something just now. Okay, this one, this part. The one that earlier I mentioned about using a wrong method but leads to correct answer. 1 over, okay, if we are using just now 1 over 2 cosine 30, 2 cosine 30 degrees. 2 cosine 30 degrees plus I sine 30 degrees. This is where just now is where it is a reciprocal. Okay, reciprocal but it's in polar. So I mentioned just now this part. Alright, which is actually, we can actually use like this. Which is actually in terms of mathematics, it is still correct method. Okay, because a reciprocal is 1 over something which is the whole thing to power minus 1. So I mentioned earlier, let's say we use De Moivre's theorem. According to the theorem, what we need to do, all right, according to the theorem, De Moivre's theorem, n power for the modulus, we raise to that power n. And for the argument, we multiply. This is actually from the theorem. Okay, we multiply. Okay, so you will see 2 power minus 1 is actually 1 over 2. Okay, and then cosine minus 30. Minus 1 times 30 degrees is minus 30 degrees. You actually get the same answer, because then we write our angle in terms of positive. So you got like this. Okay, and if you compare this and this, it's actually is the same, isn't it? It's the same answer. Okay, but theorem, De Moivre's theorem is n is positive integer. So this is not positive. This is not positive integer. So which means we cannot apply the theorem. Okay, but if you do that, actually, you see, it leads to the correct answer also. Somehow, so that's why sometimes there are cases whereby we use maybe a wrong method will give us also correct answer. So if let's say during exam, if people use De Moivre's theorem for something like this, people will just get answer for just one last one. Okay, because by right we cannot apply the De Moivre's theorem when n is not positive integer, because that is theorem. Okay, n has to be positive integer. Okay, so this is just what I would like to highlight. Okay. All right. Okay, let's move on. It's already like almost 9:30. Okay, so part B, I think you can do similar. All right, to this part A. Question 8. All right, question 8. I think this one you can do, isn't it? Just write the following expression in the form of A plus BI. So you are given a question. So basically, I think question 8 is similar to like question 2, question 3. Okay, which is just a quotient. Okay, quotient and product. Just that for B, you just need to multiply first. Okay, so question part B, 8B is actually is similar to question 3 part B also. You multiply, all right, the numerator, and then you divide. Then you just multiply by conjugate. Okay, so basically, question 8 I think should be okay for A and B. You can do this. Question 8, Okay, question 9. Okay, this one also I think you can do this. Okay, it's just that maybe your Z1 and Z3 are not just in the form of A plus BI. They are in quotient form. So again, what you need to do, you just need to divide first. Okay, to get your Z1 and Z3 in terms of A plus BI first. Okay, Z2 is already in the standard form, A plus BI. But Z1 and Z3, you got to divide first, get your Z1 and Z3 in terms of A plus BI, then only you can proceed for A's, A, B, C, D, E, F. Okay, it's just that you have to be very careful, especially like B. Okay, there's a bar there. Okay, so make sure, all right, make sure when there's a bar, you make sure you conjugate that expression. Okay, that means for B, okay, for B, all right, you have your Z2 bar over Z3. So make sure that Z2 is given as 3i plus 3. Okay, they just want to confuse you. Okay, Z2 is given as 3i plus 3. That means it is in this form, 3 plus 3i. So when it comes to Z2 bar, it is 3 minus 3i. So just make sure that you don't make that mistake. Okay, all right. So you have that Z bar there. Okay, so that's what you have to pay attention. Okay, and again, as I said, Z1 and Z3, make sure you write in the form of A plus BI. Or anybody has done this B? What's the answer? Anyone? For those who have done for 9B, anybody has the answer for 9B? Anyone? Okay, so that means anybody has done?
Oh,
Okay, so
final
if
answer, madam.
okay, final answer if you have done. What do you get?
In polar form, I got
Yeah, the answer is
Z153 over 5,
say again.
Z153 over 5,
Oh, set 153 over 5
over 5, and cos 40.6.
plus
40.6.
40.6 degrees.
Yes.
This one you got? All right. Okay. Anybody else got any different answer?
I got different answer, madam.
Okay. What do you get?
3 cos 270.
3
3
cos
cos 270.
this one.
That one.
That means for the Z2 bar divided by Z3, eh? Okay. Any other answer? Any other answer? Okay. What did you get for Z3? Anyone? When you divide two complex number, Z3, 3 minus I over 4 minus I. What do you get? Shafiq, what do you get for Z3?
Madam, actually I wrote the wrong question.
You wrote. This is for question what? This is not question 9. This is not question 9B.
I wrote it in terms of Z2 bar over Z1.
Oh, okay, all right, okay. So it's a wrong complex number for denominator.
Yes.
Okay, Shami, Z3. What is Z3? Or what is Z3 in terms of A plus BI? What is Z3 in terms of A plus BI?
Or Z3, madam.
Huh?
Z3.
Z3.
I did do
Z3 for Z3 kan is in quotient 3 minus I over 4 minus I. So what is the answer for Z3 in terms of A plus BI? Means that you have already divide those.
I did divide then I just put it in, and then 4 minus I multiply with 3 minus 3I.
Oh, okay. Okay, okay, let's look at this quickly. Z2, that means Z2 bar over Z3. Okay, by right, if you want to do this, that means Z2 is just now we will say that 3 plus 3I. So it should be 3 minus 3I. So that means 3 minus 3I. This is for numerator. Okay, Z3 is actually 3. Okay, minus 3I divided by 4 minus I like this. So you just do like just now. What did you say just now?
I put
So
4
you,
minus I at the top.
okay. So that means you are using the multiplication like this.
Yes, madam. No. Over 3 minus 3I.
4 minus I over 3 minus 3I like this. Is
It's
it like
3. 3 minus 3i times 4 minus I over 3 minus 3i.
3 minus 3i times 4 minus
I
I
over
over,
3 minus 3i.
yeah, like the one that on the screen.
Madam,
Yes.
he mean by the whole thing over 3 minus 3i.
Yes.
Uh, the whole, okay, maybe I don't I don't quite get you. Okay, again. So Z bar, Z2 bar over Z3. Okay, so it will be 3
3 minus 3i
3i. Okay,
and then multiply with 4 minus I
4 minus I.
and then over all of them of 3 minus 3i.
Like this.
Yes.
Oh, same lah just now. It's the same.
Uh,
It is the same. If I write like 3 minus 3i, okay, and then I said multiply by 4 minus I like this, right? So it means because of this is a multiplication, okay, so it means it's the same thing like this one, because then this is a multiplication, right? So the whole thing divide. All right, it's the
Correct.
same, it's the same expression. This and this is actually it's the same expression. All right, okay. So can we cancel this and this? So if this is the expression, by right we can cancel, isn't it? Isn't it?
Yes, madam.
So then it's just 4 minus I. So what is in polar? So then answer wants us in terms of modulus and argument, that right expression in polar. Okay, so that means if we compute R, 4 squared plus 1 squared,
70.
right? Okay, and then theta, tangent inverse, minus 1 over 4. Okay, so what is that? Let me, tangent inverse, okay,
14.03.
and then minus 1 over 4. Okay, minus 14, isn't it? You got something like minus, calculator will give us in terms of minus 14.03 whatever, 04. Okay, or maybe we can say minus 14, okay, to the nearest. But again, all right, our complex number here, 4 minus I, is in quadrant 4 also, right? Okay, so it's also in quadrant 4. Okay, positive, negative. So you just need to change to positive. Okay, so if that's the case, we get something like roughly about like 3, 4, 6. Okay, do people get this answer for 9? Okay, for 9, this is 9B, isn't it? You got the same answer, anybody? Okay, anybody got any different answer? So that is our modulus and argument. Anyone? Can we do
Madam.
like this? Okay, I want to ask you, can we do like this? Can we do like this in the first place? Can we do like this in the first place for complex? Okay, just now. Okay, question. All right. Yes. Yes, just now someone wants to ask question.
Kalau pakai apa? Yang quotient of two complex number, Boleh ke?
Quotient of two complex number for this one, can? Can? Can?
Maksudnya cari Z2 dulu, lepas tu cari Z3.
Yes, can. That means you find your Z2 bar, Z2 bar in terms of polar, and then find our Z3 in terms of polar. Alright, but Z3 is a quotient just now kan. You have to change to A plus BI first, then you find in terms of polar. Okay, then only you have your polar form and polar form, then you do the quotient. Okay, back to this one. This is my question now. Okay, technically looks like some sort like in terms of mathematical expression, if you have something like this and this is the same, by right you can cancel, isn't it? Okay, by right you can cancel and something like this. Okay, however, frankly speaking, previously I have never done like this. So what I would do for this particular question actually, I will just settle this Z3 separately. Like just now, I think your friend mentioned, right? You have, are you going to like multiply by 3 plus 3i over 3 plus 3i? Multiply. Okay, so previously I have never done like this, I never done, so, okay, this is actually one answer, one answer for R and theta. Maybe afterwards, R and theta, maybe afterwards, try to, maybe I would like to ask you all to also try Z2, this one no problem, because this one is straight away you will get just now is 3 minus 3i. Okay, this is 3 minus 3i. Change to polar. Okay, change to polar. Okay, but this Z3, because Z3 is given in terms of 3 minus I over 4 minus I. So this one, you settle this one first. Okay, divide first. So you will get in terms of rectangle, you get in terms of this rectangular form, A plus BI. So once you got this, okay, then just now back to your question earlier, then you change this to polar. Okay, then only this is polar, then only you use your quotient formula, okay, for polar form of complex number. Okay, so you try to do this, because this part is the correct concept or method. All right, then if you have done this, see whether it is similar to this one or not, because if they are not, that means we cannot do this, even though technically it looks like same expression. By right in mathematics we can cancel.
Madam,
Okay, yes.
I have done that way and I got different answer.
You done this
Yeah.
so because this is actually is the correct method to do, so which means if it's different than this, that means this is actually what I showed you is actually this cannot be done. So even though technically this looks like, if it's in mathematics, if you have something like expression, this is multiplication, division, in a way is that you can cancel, but actually it is a wrong way of doing. By right, actually this is the correct way of doing. Okay, so separately we settle this one first, give it in terms of this, then only change to polar. This one you can straight away change to polar. Okay, then this is actually is the method. What answer you got for this one, Cherise? Maybe you can share the answer so that those who are going to do this, they can actually refer to the answer.
I got
Maybe you
R is
maybe you just give us in terms of your final answer in terms of polar form, which is
5.53.
okay, 5.53
Cos
cosine
negative 40.6.
cos negative 40.6. This one, is it?
Yes.
Okay, then you just need to change in terms of positive,
So I have to change the cos negative 40.6 to positive.
we change to the positive angle. So that means minus 40. Okay, so you just need to add. So you got like 319, Oops. You got like cosine 319.4. Okay.
So the angle must be positive, right?
Yeah. Angle
Okay.
is positive angle. Okay.
Okay.
All right. Okay. So the rest of you, if you haven't tried this, okay, you can look at this answer. You can compare later on. That is the answer for your Z2 bar divided by Z3 bar. Okay. All right. Okay. Question 10. Okay, 10 is also straightforward, but 10, one thing that I would like to highlight for question 10. Okay, question 10 also is the same thing that you have done previously. Okay, means that you are given a complex number in rectangular form, and then question asks you to find Z1, Z2, and then Z1 divided by Z2. So it has to be in polar form so that you can use your quotient and product just now, product and quotient formula. Okay, it's just that when it comes to part B, find the modulus and argument of I Z2 over Z1. Okay, only for this part that I would like to highlight, even though from part A you have already expressed in polar form. Okay, part A you already expressed in polar form. That means part A of the question, they already asked you to find Z1 and Z2 in polar. So that means you already find this. You already got this. Okay, you already got this. You have found this. This is for part A. Okay, you have to find that one first. Expressing Z1 and Z2 in polar from the given Z1 and Z2 in rectangular. But because part B, they ask you find modulus and argument of I Z2 over Z1 squared. Okay, this is the part that I would like to highlight is because of this. Okay, the expression I Z2. So even though you already have your Z2 in terms of polar. Okay, in terms of polar. So when it comes to this one, you cannot simply multiply I to your polar form. So which means you cannot just simply like I times R1 cosine Z2 Z2 because of R2 cosine 2. You cannot do this. We cannot simply multiply I to that. Okay, because why? We cannot do that because I is our complex number in this is imaginary part. If it is just I alone, okay, that is actually is a rectangular form of complex number. Okay, this is just a rectangular form. This is rectangular form. This is polar. So polar multiplied by rectangular. So you cannot do that. Okay, so you cannot do that. So to answer for B, you got to first multiply I with the Z2 in terms of rectangular first. Okay, so you got to do that first. So which means this is going to be your 3I minus Z3 I squared. And then don't forget that I squared is minus 1. So then it becomes your positive Z3. So that means the complex number in rectangular form is Z3 plus 3I. Okay, so this is the one then you change to, okay, this is the one then you change to polar form. So once you have changed this to polar form, then only you can do this. Okay, you can do this. That means you change this to polar form, then only you can divide by Z1 with the polar form just now because Z1 is already in polar form that you have found. Okay, so then you have polar form divided by polar form. You use our quotient rule, then only finally you use our De Moivre's theorem with the power. Okay, all right. Okay, so that is for 10B. Okay, I hope everybody understand for 10B. Okay, all right. 11. Question 11. Question 11. In fact, 11, 12, 13. 11, 12, 13. These are all now exponential form. Okay, 11, 12, 13 is all about exponential form of complex number. So again, exponential form in the form of RE power I theta, and theta has to be in radian. Okay, this theta has to be in radian, cannot be in degree. And then to compute for R and theta, it's a similar like polar form, all right, where you have your R is square root of x squared plus y squared, theta is your tangent inverse. So it's the same formula, okay, for R and theta. Okay, so basically, all right, basically for exponential form, like for question 11, you are given A, C, D are given in terms of rectangular. B is already given in polar. If you have in polar form like B, straight away you can extract your R and theta. Okay. Okay, for B you can straight away extract your R and theta. So that means for B, your R is 4, theta is pi over 3. So you can straight away write in terms of exponential form. Okay, whereby A, C, D, you still need to compute R and theta accordingly. Using the same formula, R equals to square root of x squared plus y squared. Theta is tangent inverse y over x. So I think 11 should be okay. Okay, so 11 should be okay for A, B, C, D. Okay, so this one should be okay. 12. Write the following numbers in the form of x plus iy or yi. Okay. This one also not that difficult, isn't it? It's just that you need to just extract what is r and theta from the question, because question is already given you in terms of, for example, A is you are given 7e 2 pi over 3i. So straight away extract for r, extract theta from the expression. Then if you want to find the form of x plus yi, just use your polar form expression. That means 7 cosine 2 pi over 3 plus I sine 2 pi over 3. Then compute. Okay, compute this. Okay, you compute. Then you will write in terms of a plus bi or x plus yi. So also straightforward. Okay, write your final answer in terms of that. So for 12, ABC is all like that, except for maybe can people tells me for C, what is R and theta for e power 3 plus pi over 4i. Remember, we have done this type of questions in our exercise previously, in exercise in the section. What is R and theta?
R
Anybody?
is 1.
R.
R is 1.
Shabi. Sure.
E.
Sure. Huh?
E.
E only?
No.
E3.
E power 3, right. Remember this one?
R is 2.
This one, remember, is the same as e power 3 times e power pi over 4i. Because remember, this is exponent rule. Okay, so then this is your r. So this is your theta. Okay, so then r is e power 3. Theta is pi over 4. Then you substitute into, again, this r cosine theta plus I sine theta, and then compute straight away. Okay, all right. Okay, so that is 12C. So what's the answer? Answer is actually, okay, because theta is pi over 4. cosine pi over 4 and sine pi over 4 is the same, isn't it? So your answer should be e power 3. And then cosine pi over 4 is either you say 1 over sec 2 or 2 over sec 2. So 2 over 2, but because of this is cosine 2, sorry, this is, yeah, cosine pi over 4, right? So that is just, then you have your r is e power 3, so it's the same, e power 3 sec 2 over 2i, isn't it? Okay, that's the answer, right, for 12c. Okay, all right, so, and then, okay, 12, 13, okay, 13, okay, 13 also now, this is like exponential as well as because of the power is actually De Morgan's theorem. Okay, for 13, express the complex number z equals 1 minus sec 3i in the form of r e power I theta and deduce the following complex number in the form of a plus bi. So question asks you for z power 4 and z power 7. Is it understood? Okay, from z equals 1 minus sec 3i, you are to find, okay, definitely you have to find your r and theta again. Okay, because you need to write first in the form of re power I theta. So they want you to write in terms of exponential form. So you need to find, okay, to find your r and theta. And then second, you write in the form of re power theta, I or I theta. Okay, I theta or theta I. So you write in that form. So you find your r, you find your theta, so you can write in this form. Okay, and but make sure theta is in radian. Okay, theta must be in radian. So that is the first part. And then second part is deduce the following complex number in the form of a plus bi. Okay, then only you start answering your part A. Okay, and then after that part B. So part A basically they want you this z power 4. All right, okay, so z power 4, that which means this is the same thing as 1 minus z 3 I power 4, which means you've already gotten your r and theta from here. You have your r and theta, so you can write your polar form of a complex number. Then just raise to the power 4. Then you use your De Morgan's theorem to get that. Okay, so use your De Morgan's theorem, which means that it will be r to power 4 and then cosine 4 theta plus I sine 4 theta. So whatever your theta is, okay, whatever your r is, then only you get your answer in polar form. But question asks you in terms of a plus bi and then compute. Okay, then compute. Because then final answer must be in the form of a plus bi in terms of rectangular. That's the last answer. Okay, rectangular form. So for both A and B, you do the same thing. Okay, for both A and B also the same. Okay, so do the same thing. Then 14 basically is also similar to this A and B. Okay. All right, question 14 also similar. So question 14 is actually similar to just now A and B. These are all to power. In fact, I think for this type of question also, question 14 also is similar to your assignment, isn't it? Assignment 3. In fact, assignment 3, I think there's like all in one type of question where you have power and then multiplication, division some more, okay? And all each complex number rectangular form is all given in terms of power. So I think your assignment is actually that perhaps it's more complicated. It's just that make sure for this question 14, all right, pay attention to F. Okay, pay attention to F because F has a bar. Minus 5 minus 2i power 5 with a bar. Okay, with a bar there. So what does it mean? The bar, all right, this bar is conjugate. That is the last thing that you are going to take care. Okay, this is the last thing that you are going to take care. So that means you need to, what is the step for this question? Okay, first step is you change your minus 5 minus 2i to polar form. All right, that means find r and theta. And then second step, use De Moivre's theorem. All right, to take care of power 5. All right, and then compute your polar form. Compute your polar form into rectangular form because you want to, in terms of rectangular, a plus bi. Then only finally, all right, take care of the bar, i.e. state the conjugate. Okay, state the conjugate expression of your final answer. Okay, your answer in part 3. Okay, your answer in part 3. Okay, that's what you need to do. Okay, because the bar, it will be the last step. Okay, for the final answer. So don't try to find the conjugate because you have a power here. Okay, you got the power. The whole thing to power. Okay, so you settle this part first. Minus set 5 minus 2i into polar form. And then only use De Moivre's theorem to take care of the power. Okay. Then only you compute your expression, your polar into your rectangular form a plus bi. Then finally you state your last answer as the conjugate expression because of the bar. So that is actually it's a step for F because of the bar. Okay. All right. So I think you can actually do this again. You can actually do all this. It's just that certain question, perhaps it will be like very long. Solution, it can be quite long. Depending on the question, it can be quite long. So it's a lengthy step actually. Okay, so you just need to do it patiently. Make sure you have a calculator. You calculate correctly. Okay, especially the angle. State the angle. All right, correctly. In terms of angle, remember is in the form of a positive angle. Okay, it's a right angle in the right quadrant. Okay, things like that. So you have to like really do this very carefully. Okay, make sure you really answer the question carefully. All right. All right. Okay. Anybody got any question?
Madam, I have
So
a
next,
question.
yes. Okay.
Let's say the product of polar form, the Z1 times
Okay.
Z2. The angle I
Okay.
got more than 360. Do I need to find
Yeah.
between 360?
Yes. You have to. Correct. Because for polar form, okay, this is actually okay. Question is like this. If question just like I mentioned earlier, just find modulus and argument. Full stop. Okay, find modulus and argument. That's the question. So that means they just want you to state what is r equals, what is theta equals. And then if your theta is actually beyond 360, like just now we have 390 degrees. Okay, if people write 390 degrees and people write 30, right? Okay, because if you subtract 360, all right, you got 30 degrees. So one person write 390 or another person write 30 degrees. Okay, we will accept both actually. Okay, we will accept both. Okay, all right. We don't actually, we are not really that strict in that sense because the question just asks you to state only the argument. But if let's say question say that, you know, you find, given this Z1 and Z2, find Z1 and Z2, full stop. Or find Z1 and Z2 in polar form. They mention like that. That means you have to write your final answer. Z1, Z2, you have to write in terms of R. This is what you need to write. R cosine theta plus I sin theta. So even you have to write this as your final answer. Okay, then you must pay attention of this. Okay, pay attention to this, that your theta has to be between 0 degrees and 360 or 0 to 2 pi. So if it's beyond 360 or beyond 2 pi, you write in terms of, you subtract your 360 degrees. Okay? All right, Cherise?
Okay, madam. Thank you, madam.
Okay? Okay, welcome. So it depends on the question. It depends if they just ask you to state only, like this one, state only. So we at this one we are not really that strict. So you write beyond angle beyond 360 also we accept. Okay. Okay. Any other question for complex number? Okay. If not, then next week again our last session. So again next week also we have to do some sort like marathon also. That for our vector question. So vector also is actually is a lot, but I think it's just all are just computation, and then there is no like application. So I think you can actually do this. It's just that also for certain question it can be like quite long, all right, to get to the answer. But you must also compute this correctly. So we will discuss a vector next week. And on Tuesday, we will finish up our last section for vector. Okay, we still have one last section, which is our cross product. So that one we can inshallah finish by next Tuesday. And again on Tuesday, if let's say we have time, we still have time. So maybe I can just look at some of the questions from the book. Okay, and then we will continue doing that during our tutorial next Thursday. And I think because next week is the last session, perhaps the other group also, your section 2/1 also, if you would like to join in the morning, perhaps we can have a morning session also for next Thursday. Or perhaps everybody join like today for the last session for next week, Thursday morning. Okay? All right. Any question? Any other question before we end the session?
No, madam.
All right. So again, for those who have not catch up with the rest of the question or doing a lot of these questions, so please do keep up, and please do keep up with all the questions. Okay, you got to start your revision now, for the final exam, because again, as I mentioned earlier, your final exam for technical maths is on the first day. Okay, it's on the first day of exam week. So you only have like a few more weeks, okay, before your final exam. So you must start your revision now. And regard or whatever that we discuss as also part of the revision for the final. Okay, and definitely whatever that we discuss during tutorial, there will be question like this similar type in the final exam. Okay, because final exam definitely there will be complex number, there will be vectors, okay, as well as trigonometry. Okay, the one that is not there is only matrices. Okay, matrices is not in the final exam, but the rest of the chapters will be in the final exam. So regard whatever that we discuss during tutorial, during lecture also next week. Okay, regard this as part of the revision also. So make sure that everybody do listen, attend. I know that even though I cannot see all of you. Okay, I have a lot of people there joining, but I do not know how many in front of the whatever device you are using, okay, and listen carefully, or follow whatever that we are discussing. So I do not know how many are doing that. Okay, but whatever it is, again, you make sure that everybody, all right, do your part for the final exam. Okay, if you want to get good grades, you make sure you understood, especially the last part of the session is very important. Okay, because we don't have many time to discuss question later. All right, okay. So I think if there's no more question, then perhaps we can end the session. Okay, so thank you very much for your attention, for your listening, as well as for sharing, whatever answers. Okay, so I will meet you again next Tuesday. Okay, and stay home, stay safe, everybody. Follow SOP. We are now in MCO. All right, okay. So really, please stay healthy, stay safe, because final exam is just around the corner. All right, I will meet you again next week. Okay, thank you, everyone.
Okay, madam.
Okay, all
Thank
right.
you, madam.
Thank you, madam.
You're welcome.
Thank you, madam.
Don't forget.
Thank you, madam.
Okay, all right.
Thanks,
Thank you, madam.
madam.
Thank you, madam.
Thank you, madam.
Okay, welcome.
Thank you, madam.
Okay, thank you.
Thank you, madam. Assalamualaikum.